Hello, students and listeners at home. My name is Iwueze Tochi from St. Charles College in the Department of Physics. Today, our online lesson is on reflection of light. Now, let's go to the specific objective. By the end of the lesson, you students will be able to define light, list various sources of light, define luminous and non-luminous bodies, list various ways of transmission of light, define rays and beam of light. Define rectilinear propagation of light, list effect of rectilinear propagation of light. Now, let us go into the lesson proper. Light. Light is a form of energy that travels from one point to another without any material medium. Light is a form of energy that travels from one point to another without any material medium. So, light does not require a material medium for propagation. For instance, you have the sun, the light from the sun that used to come to the earth from a very far distance. You see, there is no medium that is required, even though air, the available air in space, is not needed for light propagation. Even though when you go in a very tight place and cover the room, cover the environment without allowing air to come inside, light can still travel in that area. It can still propagate. That to show that light does not require a material medium for propagation. Sources of light. There are two sources of light. Artificial sources of light and natural sources of light. Natural sources of light are the sources of light that are original. They are those sources of light that are made by God. Example, the sun and the stars. Artificial sources of light are the sources of light that are made by human beings. Example, candle, electric lamp, incandescent light, and fluorescent light. Now, luminous and non-luminous bodies. What is a luminous body? A luminous bodies or sources are those sources that generate and emit light by themselves. So they are those objects that emit light by themselves. Those objects that emit light by themselves are called luminous bodies. Example, you have the sun, the stars, fireflies, some deep sea fishes, and artificial light sources. So you can see that the sun generates light by themselves every day, annually, weekly, both the stars. And there are some insects that used to fly at night. When they are going at night, they show light in their body. So that is what I mean by fireflies. And some fishes in some of the ocean, some of them used to carry light in their body. Non-luminous bodies. There are those bodies that do not generate light by themselves. They are only seen when they reflect the light from a luminous body. Example is page of a book, person's face, a brick, and moon. Now I can see that someone may say that the moon that I used to see at night used to show light. No, the light that is coming from the light that you are seeing from the moon is the light from the sun that the moon is reflecting. Now let us go into transmission of light. Various ways of transmission of light. Transparent. Transparent is the materials that allow light to pass through them. A transparent material allows all the quantity of light that comes to them to pass through them. So for instance, example, you have glass and water. Translucent. A translucent material allows small quantity of light to pass through them. That will show that a translucent material absorbs some quantity of light and then allows some quantity to pass through them. So example is frosted glass and tissue paper. Like there are some glass that are very thick, that when you are looking at them, you will not actually see the other side easily or clearly. So such glasses are called frosted glass. They do not allow light to pass through them, or the quantity of light to pass through them. Another one is tissue paper. You can experiment that of tissue paper by bringing a tissue paper and bringing a torchlight. Place the tissue paper on the face of the torchlight, then on the torchlight, you are going to see that the quantity of light that will come out is going to be smaller than the original ray of light that come out from the torch. Opaque. Opaque bodies is the materials that do not allow any light to pass through them at all. Opaque bodies do not allow light to pass through them at all. Example is wood, bricks, walls, and metal sheets. Rays and beam of light. A light ray is the direction or path along which light energy flows. A light ray is a direction or path along which light energy flows. So a collection of rays is called beam. A collection of rays is called beam. Types of beam. We have parallel beam, convergent beam, and divergent beam. So a parallel beam is one in which the light rays are parallel to one another. Such light gives off parallel beam of light. A convergent beam is one in which the rays converge or meet at a point. A hand lens can produce such a beam. A divergent beam is one in which the light rays all come from a point and spread out or diverge from the source. Now you can see the diagram on the screen. You have the first diagram is parallel rays. So the parallel beam there, you can see the arrow that shows the direction of movement of the beam. Now you can see the second one. The second one is convergent beam. Look at the arrows, where the arrow is coming from. These beams all come from a different point. They meet at a point. Now you can see the third one. The third one is divergent beam. This divergent beam, they all emanate. They started from a point, then spread out. Rectilinear propagation of light. Rectilinear propagation of light is the phenomenon by which light travels in a straight line. So two natural effects of rectilinear propagation of light are shadow and eclipse. Shadow and eclipse are the effects of rectilinear propagation of light. So shadow is an area in which light rays from a source cannot reach. A shadow is an area in which light rays from a source cannot reach. So shadows are of two forms, umbra and penumbra. Umbra of shadow is the region of total darkness. Penumbra of shadow is the region of partial darkness. Now you can see the diagram on the screen. The diagram on the screen is showing the sun, the earth, umbra and penumbra. Now, the yellow object is the sun. The blue object is the earth. Now, the rays of light is coming from the sun to the earth. Now, as the earth block these rays of light, the shadow of the earth will be cast at the back of the earth. Now, there are areas that light could not reach at all. There are areas behind the earth that light from the sun could not reach. That area is called umbra. You can see it on the screen. The place that is very dark is called umbra. Then you have a fairly region that is called penumbra. You can see it's very light. You can see the difference there. You have light, dark, and total dark. The one that is very dark and the one that is fairly dark. The one that is very dark is umbra, while the fair one is called penumbra. Eclipse. Eclipse is a region of a shadow cast by one heavenly body on another. Eclipse of the sun. Eclipse of the sun occurs when the moon is in between the sun and the earth. The moon blocks rays of light from the sun from reaching the earth. The earth appears to be dark. People on the surface of the earth cannot see the sun. So you can see that in this eclipse of the sun, the moon is between the sun and the earth. So you know that the planet system, they all revolve around one another. So as they revolve, as the moon is the satellite of the earth. As the moon revolves around the earth, you see that at a certain point, the moon is going to block the rays of light that are coming from the sun from reaching the earth. So therefore, the shadow of the moon will be cast on the surface of the earth. Therefore, people that is staying on the surface of the earth will not be able to see the light from the moon. So we then have eclipse of the sun. Now, the moon and the earth may be in position where the rays at moon age intersect before reaching the earth. Under such condition, an annular eclipse is formed. A ring of light is formed around the shadow of the moon. So you can see that in annular eclipse, the rays of light that is coming from the sun intersects before reaching the earth. And in annular eclipse, a ring of light is formed. You can experiment it by bringing an object and a torchlight. Now place the object on a table and place the torchlight on the table. Now on the torchlight, allow the rays of light to beat on the object. Then watch the image of the object form on the wall. You are going to see that the shadow of the image will be cast on the wall, and you see a ring of light. A ring of light will then surround that object. So that is what happened during annular eclipse, that a ring of light is formed around the surface of the earth as the moon blocks the rays from the sun. Now you can see the diagram of what I am telling you. Now look at the diagram on the board. You see the white object is the moon. The yellow object is the sun. Now you can see the earth there. You have the earth there as having blue and white color mixed up and some green color. You see it there. Now you can see a green track, a green circular line with arrow. The green track is the path through which the moon takes to revolve around the earth. You see a blue path, track. The blue track is the path along which the earth revolves around the sun. Now the moon revolves around the earth while the earth revolves around the sun. Now as the moon is going around the sun, at a certain point, you see that the moon will come in a position between the sun and the earth. So as the moon comes in between the position of the sun and the earth, the rays, the shadow of the moon will then block the rays of light coming from the sun from reaching the earth. Therefore, the shadow of the moon is then cast on the surface of the earth. People within that region will not see the rays of light coming from the sun. Eclipse of the moon. Eclipse of the moon is when the earth is in between the sun and the moon. The earth casts its shadow on the earth, on the moon. Now listen, the moon revolves around the earth, and the earth revolves around the sun. So these two bodies, they all move, they all revolve around. Now, as the earth is moving around the sun, at a certain point, the earth will come and stay in a position that it will be in between the sun and the moon. Therefore, the rays of light that are coming from the sun will be blocked by the earth from reaching the moon. Therefore, the shadow of the earth is then cast on the moon. You can see the diagram on the screen. You can see the diagram on the screen. The yellow one is sun. The white objects you are seeing there is the moon, and you have the earth having blue and mixed up colors there. Now, pinhole camera. Pinhole camera consists of a light-proof box, one end of which has a small hole made with a pin or a needle. The opposite end has a screen made of tracing paper or glass. The pinhole light passes through it and forms an image on the screen. If the screen is replaced with a photograph paper, the image will be formed on the photograph paper. Now listen, this pinhole camera is being constructed with, like for instance, a carton paper. Now you use the carton paper to make a box, construct a box. Then in front of that box, you make a small hole at the center of it. Then inside that box, opposite to the hole that you made, use a white paper and place on the wall of that box, facing that small hole that you made. Now, if you bring an object, if you place an object in front of that open hole that you made, in front of that open box that you made, you see that the image of that object could be seen as an inverted form inside the box. Inside the box, it will be formed on that white paper that you put that is facing the magnification of pinhole camera. Magnification produced by pinhole camera is the ratio of the size of the image to the size of object. Magnification is the ratio of the size of image to the size of object. Now you can see the image that is produced by a pinhole camera. You have the rectangular box there is the pinhole, a sketch of pinhole camera. Now you see the image form, you see the object form. Look at the object, the height, the arrow that's showing you A to B is the object height. Now you have the image that is formed on the rectangular box is the image of the object, that is the height is B prime to A prime. Now the distance of the image on the pinhole camera is A prime P, A prime P, and B prime P. That is the distance of the image on the pinhole camera. Then the distance of the object is BP and AP. Magnification, the formulas of magnification. M is used to represent magnification of a pinhole camera. Now, size of image over size of object. You can as well state magnification as height of image over height of object. You can as well state magnification as length of camera over distance of object from pinhole. You can as well state it as distance of image from pinhole over distance of object from pinhole. Now, magnification as seen from the camera above. So you have B prime, A prime, B prime, A prime over BA. Now that is B prime, A prime is the height of the image. You can check it in the rectangular box as seen in the diagram above. Now BA is the height of object. Now B prime P, B prime P is the distance of image from the pinhole. The distance of image from pinhole is B prime P over BP. That is, BP is the distance of object from pinhole. The distance of object from pinhole. Now you have also A prime P. A prime P, A prime P is also the distance of image from pinhole, and also over AP, which is the distance of image, the distance of object from pinhole. Now, example. The height of an object placed at a distance of 60 cm from the hole of a pinhole camera is 15 cm. If the length of the camera is 10 cm, calculate the magnification produced by the camera and the height of the image. Solution. Now, magnification represented with M, capital M, is equals to length of camera over distance of object from pinhole. Remember that in the problem above, in the question above, we are given the length of camera to be 10 cm. And we are given the distance of object from pinhole to be 60 cm. So when we substitute it inside the formula, we then have 10 over 60. So when 0 cancels 0, we have 1 over 6 as the magnification. Now, for us to find the height of image, we have that magnification is defined as height of image over height of object, and also length of camera over distance of camera. You know, in this certain problem, There are certain times that you equate two formulas in order to get a missing term. You say that A plus B is equals to B plus A. A plus B is equal to B, in as well, vice versa, B plus A is equals to AB. Now, we equate, but since we have already obtained our magnification is height of image over height of, then we have the h prime as the height of image, which is unknown, that's what we want to find, over height of object, which is, height of object is 15 cm, that is equal to the magnification, which is 1/6. Then when you cross multiply, you have 15 over 6 as the height of image. Then when you divide, you have height of image to be 2.5 cm. Summary. Light is a form of energy that travels from one point to another without any material medium. Sources of light, natural and artificial sources of light. Luminous bodies are those materials that emit light by themselves. Non-luminous bodies are those bodies which do not emit light by themselves. Transparent materials are those materials which allow light to pass through them. Translucent materials are those materials which allow small quantity of light to pass through them. Opaque are those materials which do not allow light to pass through them at all. Rays of light is the direction or path along which light energy flows. Beam is a collection of rays of light together. Beam is a collection of light of rays together. Rectilinear propagation of light is the movement of light in a straight line. Two natural effects of rectilinear propagation of light are the shadow and eclipse. Now, having come to the end of the lesson, I want to use this assignment to test your understanding on the lesson that you have learned. Assignment. Number I, define light. I, list sources of light. I, explain luminous and non-luminous bodies. IV, explain transparent, translucent, and opaque bodies. V, define rectilinear propagation of light. VI, list two natural effects of rectilinear propagation of light. Explain eclipse of the sun. Now, do the assignment and submit through my WhatsApp number. My WhatsApp number is 07035779845. You can as well reach me through my email address. My email address is Tochi Iwueze @gmail.com. Thank you for listening. May God bless you. See you next time.